For 40 years, I've been obsessed with a problem. The problem is to define pathways that people, businesses, and even whole economies can thrive in a world where the population is growing extremely rapidly and all of the new people want access to the benefits of modern economy and modern science, and yet where our resource base is extremely constrained, increasingly constrained, and our environment increasingly stressed. I got interested in this problem from my colleague, my mentor, R. Buckminster Fuller, who used to say that nature wasn't designed for humans to have to choose between a healthy environment and a healthy economy or a healthy society. I spent 40 years working inside of every imaginable kind of institution, from large, huge corporations to small companies, nonprofits, international agencies, and local governments, and trying to understand how they use resources, why they do, and how they could possibly change. About 7 years ago, I started writing a book to summarize what I had learned, but I decided that I needed to go back and ask a question. Do we really know? Do humans have the capacity, the knowledge, to actually create a sustainable society for 8 billion people? And so my colleagues and I began to inventory various types of innovations. Innovations, social innovations, like Ezio talked about this morning, and also technological and scientific innovations, to try and understand what impact those innovations might have on resources. We began building a database and publishing a newsletter of these innovations. And what we found was breathtaking. We found new companies spinning out of university and college laboratories all around the world. We found new companies being started by entrepreneurs to change the way that businesses do business. We found large companies setting aside their pre-existing consumption ideas about how they do business and asking basic questions and developing new innovations. And what we found was a potential for human beings to do something that no one ever dreamed was possible before. And that is to produce wealth on a vastly increased scale with a tiny fraction of the resources that we use per capita or per unit of wealth produced. And I want to share a few examples. But first I'll tell a quick story. How many of you know what this is? Terry Allen, who's in the room, cannot, was a student of mine at Wesleyan when I was working on this problem, so she can't answer the question. This is called a preform. It's a 2-liter soda bottle before it's been blow molded. I learned a lot from this bottle because when I first started doing consulting work, my company was asked to go in and help the largest manufacturer of these bottles figure out how to save resources in their manufacturing plant, energy and resources. In the 3 months my colleagues and I were in the plant trying to do that, the company's product engineers figured out how to change the arrangement of molecules to create screens on individual molecular levels in the bottle and make the bottle twice as strong while taking away 30% of the material composition of the bottle. This was incredible to me. Think about it. I want to repeat it. They took away 30% of the product and made it twice as good. How is that possible? I want to show you. It's by doing better with less, what I call resource performance. Another word for that is dMass. The D in dMass stands for reduction, and it stands for design. The reduction of resource mass through design. So here's how it works. This is a company, but it could easily be a community or it could be an entire economy. That community exists to produce things that people want, things that people need to make their lives better. People buy products because they want things to make, they perceive that the things that they buy will make their lives better, make them more secure, make them healthier, make them look better, whatever. To get those things, the company has to has to get resources. Excuse me. The resources, the company pays to have resources dug up out of the earth, ground up, processed, shipped around the world, processed again, made into products and shipped around the world again to get to you. Everything, this is very important, everything in our built environment, the computer, the projector that runs this, the seats that we're sitting in, the building itself, are the Earth's crust reorganized by design. That's what we do. We reorganize the Earth's crust by design. Now, when we do this, we always produce byproducts. We produce waste and pollution. But remember, waste and pollution are only and always valuable resources that got dug up out of the ground, processed, shipped around the world, processed again, and got lost in the process. Okay? And I used to work with my clients, I used to say to them, the trick who wanted to reduce their environmental impact, I always said, if you don't use it, you can't spill it. Because no matter how good we are at trying to manage waste, the bottom line is the more we use, the more we lose. So we've been focused on this back end. All of our concerns about sustainability have been focused on reducing what comes out of the back. But now we have to move to what goes in. We have to think about what goes in and the relationship to what kinds of benefits we're producing. Now notice that when I introduced that first arrow up in the top right-hand corner, you probably thought I meant products that people buy, but I didn't. I meant benefits. Because people don't buy products because they like products. They buy them because they perceive that they'll get benefits from them. And here's the wonderful thing. Benefits don't weigh anything. Products are the messenger for the benefits, not the message. They are the medium by which we get benefits to people. And now we have to, as designers, ask, how can we get more benefits to more people with less resource mass, drastically less resource mass? We don't need toothpaste. We need oral hygiene. We don't need batteries. We need portable energy when we want it. We don't need washing machines. We need clean clothes. And these companies that we've been discovering, these innovators around the world, have been figuring out how to do these kinds of things and completely disintermediate the products that we think of that make up such a big part of our everyday lives. And it does by using science. So right now we have a large portion of the world supported by a certain amount of resources, and we need to drastically change that by using science to be able to make the resources go much further. I don't have time to really share these examples with you, but let me just say that major corporations are changing the way they think about the products they build because they're already aware of the resource crises that are facing them and the irregular, unreliable supplies of those resources. This is a technology that came out of bioremediation, the kind of thing that Julie was talking about. It's a pattern of molecules on the surface of a shark skin, that keeps the single-cell organisms from attaching to the shark and communicating with each other to form communities that could interfere with the shark's ability to move stealthily through the water. This company figured out that molecular structure and has been able to reproduce it to make films that can now not only be used on ships to make ships go more smoothly through the water, but also to put on the surface of tools and instruments in hospitals, of countertops and surfaces in kitchens and bathrooms. This technology has the ability to entirely eliminate an entire toxic chemical industry for killing germs. Okay, this is a concrete system that makes a cloth out of concrete and can be used for structural applications that reduce the amount of concrete necessary to do a job by as much as 95%. These are airplane parts printed by 3D printers, just like the ones, the printers in your attached to your computer, but to actually print parts, three-dimensional parts that are now being used in aircraft. This is a wallpaper. This is a wallpaper that contains billions of little tiny organic LEDs that are smaller than grains of sand, and when 3 volts is applied to the wall glows and lights up. This technology has the potential to eliminate the entire lighting infrastructure of buildings, not just the bulbs, but the lamps and the ballasts and the wires and the control boxes and everything else associated with them. Electrolux has committed itself to making a washing machine within 10 years that doesn't use water. So, 3 important concepts I want you to just learn quickly. Embodied mass. Embodied mass is the total resources that go into making the products we buy. You buy a shampoo bottle and it says it has 8 ounces of net, 8 ounces of shampoo. That bottle, if you knew all the resources, all the amount of the Earth's crust dug up to get that shampoo bottle to you, you would find that it probably weighs 10 pounds. Okay? And the trick is to understand the embodied mass of every product we buy. This product benefits is a nice little example here of people don't buy lawnmowers because they like lawnmowers. They buy them because they want short grass. Well, there are numerous companies in the world working on strains of grass that don't grow more than 2 inches high. And so the lawnmower companies are going to find themselves in some difficulty. Naked value is the essence. Naked value is the value that a product delivers to a customer unadorned by all the excess material resources. A vast proportion of the resources that we use every day are being used to just move around more resources and not deliver value. So the naked value in the shampoo is a tiny, tiny portion of what actually you see when you buy the shampoo. So, what does this mean? It means that performance is a function of a ratio between the value that we actually get from doing something and the amount of resource mass of fuels, water, and materials that go into doing it. And we can literally measure changes or improvements in performance, and we're helping companies do that. And you can plot it on a graph so you can see how much more we're doing with how much less. So, resource performance outputs. This is where designers come in. We all know that recycling is an essential part of building a sustainable society. But as philosophers would say, it may be essential, but it is not adequate. We also need to recycle know-how. Every time we use resources, we need to learn. And we need to learn to apply our best design thinking so that every time those resources get redeployed, they produce many times the amount of wealth that they produced the last time around. So, in conclusion, pollution is nothing more than wasted resources. People buy benefits, not products, and we need to be teaching our clients, teaching companies. We need to be buying products on the basis of the total amount of resources used compared to the value delivered. And most products are mostly waste. So I want to thank you. You can sign up for a free newsletter online if you'd like. It's filled with examples of the kind of technologies I just breezed over here quickly today. But thank you.